Here's an update on my custom condenser enlarger. I'm going to show you what I've done. I'm also going to explain some of the principles involved for those of you who aren't familiar with the difference between a condenser enlarger and a diffusion enlarger. This is the power supply from a PC. Some light modifications will get them putting out a steady and strong 12 volt direct current. Here is the light housing. In this light housing are two xenon tubes of continuous light, like what many car headlights are equipped with, and at the back of it is a regular quartz halogen 100-watt bulb used in enlargers commonly. My original intention was to produce an enormous amount of power to produce large prints with an intense light. And then I've come to realise with condenser enlargers, it's not so much the power, it's the efficiency that can be produced by them. Condenser enlargers are based on an intention to have a point source light. Although having a point source light is almost impossible, condenser enlarger manufacturers have done everything they can to reasonably produce an intense point source light, limited by the size of the filament in the light bulb that must exist. Two lenses exactly the same, opposite each other. Each have a focal length and a focusing point. So the way the condenser lens sees your light source is a bit of a cone. You could imagine a funnel. What happens is this gets reproduced and mimicked on the other side. And to put it simply, you end up with a convergence of light coming out of the condenser lens towards the lens. When you position the convergence of the light where it inverts on the nodal point of your enlarger lens, it becomes extremely efficient. You've actually funneled the light through the lens. Your aperture becomes almost irrelevant, assuming everything's perfectly aligned, 100% efficient, and you have an exact point source light. To make this happen, the distance between the lens and the condensers affects the relationship between the distance of the condensers and the light source, and setting your enlargement and focus is after this fact. Alright, I'll fire it up, I'll show you what I've got. As I'll turn the power on at the wall, all we're going to get is the 100-watt bulb. Now the bellows is held in place by an Oki strap. The light source is sitting on a stack of books, and I'm just going to hold the lens here. The negative I have in here is a pretty high density test pattern I made with the contact print. So by stopping down, I just find the brightest projection, and that's going to be somewhat centered to the projection. And now I'm going to move my aperture. That's wide open f4.5, and that's where it starts getting darker at f11. So that's f11. That's f4.5. I've made a little bit of difference. So f8, f4.5, you can't actually see any difference because the light's inverting through the lens. This is where a part of your sharpness comes from. You have the brightness of a lens wide open with the depth of field and sharpness of a lens that's stopped down. Like right now I'm still moving that aperture. 1, 2, 2 whole stops. If this was set up well, I'd easily be able to stop down 3 stops without seeing any loss of light in the projection. Let's turn on the xenon, which is one of 2 xenons because only one of them's working. It takes about half a minute to warm up. Your enlarger lens's image circle is like a cone coming out from the back. Now, if you move your lens further away from the film, that cone is going to be a larger image circle, which is why when we quote the image circle of a lens, it's the image circle when focused at infinity, because infinity is when the lens is the closest to the film. When enlarging with this enlarger, you can cover a larger film if you're making smaller prints. because lens further away means a closer focus, which means your lens will be closer to the paper you're printing. So when limited by your light source, your condenser size, and the image circle of your lens, you could make big prints of small film or small prints of big film. There's trade-offs. Now the next thing to do is probably to extend the slide for the light source. Try and figure a way to measure that the light source is exactly center to the condensers. Now, since I'm actually combining 3 light sources, I may actually want to box it in and put a diffuser on it as small as possible, possibly like a 5mm diameter diffused light source, so a semi-point. Obviously you've got to mount the bellows and make some sort of a cover for this electronics. Then I need to mount the lens exactly parallel and centered to the whole system so everything flows in a straight line.